Second property is we have to calculate the electric field on the Gaussian surface of an infinite plane sheet of plus q charge. So if we consider a ds surface area and we draw a Gaussian surface due to this area, it would be in the front of the sheet and in the back of the sheet in the form of cylinder again. So if we draw the normal to this surface area, it would be in this direction and electric field would be also in the same direction. And same goes with the backward side of the sheet. Electric field is also in the same direction of the normal to the plane. So if we just calculate the electric flux, we will get E into ds of let's name both of these surfaces A and B, electric field at A and B plus electric field at B into surface area of B. So electric flux would be equal to E into surface area into cos theta plus EB into surface area into cos theta. Here the value of theta in both of the electric fluxes is 0, so by putting the value of cos 0, which is equals to 1, we will just get electric field A into surface area A plus electric field B into surface area B. Here electric field A and electric field B both are equal because of the same plane sheet, which is creating the same Gaussian surface in the front of the sheet and back of the sheet. So the surface area and the electric field of both of them is equal, so we will get 2 into E into S, which is electric. So the total electric flux would be equal to 2 into E into S. So if we calculate the electric field by taking the S into to the other side, electric flux would be upon electric field would be equal to electric flux upon 2 into surface area. Now if we just put the value of Q this electric flux here, which is equals to Q upon epsilon on, we will get electric field is equals to Q upon 2S into epsilon naught. So now electric field is equals to Q upon 2S into epsilon naught. So the charge density on this infinite plane sheet would be equals to sigma equals to total charge upon the total surface area of this sheet, which is equals to S. So by substituting the value of Q here, we will just get electric field equals to sigma into S upon 2 into S into epsilon naught. Here S and S are both of the both surface area of that ds surface area we took from the electric sheet, which is this surface. So just by getting the values here, we'll get electric field equals to sigma by 2 epsilon naught. So just by knowing the value of sigma, the charge density of the infinite electric sheet, and the value of an epsilon naught, we can calculate the electric field on the Gaussian surface. So let's proceed to the next property. Now the third property is to calculate the electric field due to this thin spherical shell on this Gaussian surface. So we can there is only a single surface area, and the electric field is the angle between the electric field and lines and the normal is also 0. So we can directly write that electric flux is equals to A into surface area. Now we know that the electric flux is equal to E into 4 pi r square. Here r is the distance between the center of the shell and the Gaussian surface, and this r is the distance between the center and the surface of the sphere. So we know that the electric flux is also equal to Q by epsilon naught. So by just putting the value of electric flux here, we will get Q by epsilon naught equals to E into 4 pi r square. So now by taking the values to the left side, electric field would be equals to Q by epsilon naught into 4 pi r square. So this is the formula for calculating the electric field on the Gaussian surface due to a thin spherical charge sphere. So electric field would be equal to Q upon epsilon naught into 4 pi r square. By knowing the distance between the center and the Gaussian surface and the value of epsilon naught and Q, we can calculate the electric field on the Gaussian surface. So thank you guys.